So students, we are going to start with a new lecture in object-oriented system design series. This lecture will be consisting of two topics. One is the programming style and the second one is the difference between the OOPS and the POPs, where OOPS represent the object-oriented programming and POPs represents the procedural-oriented programming, the conventional version which we were studying earlier, right? The example of OOPS is C++, Java, and example of POP is what? It's C, the procedural normal language. Now, see, first thing we need to understand that what is the difference between object-oriented programming and procedural programming. We are at this stage right now. We have already studied the procedural programming earlier, and in this particular concept, object-oriented programming has also been seen as in all the concepts. So you are aware of all the concepts of OOPS and the procedural programming. So now we see the difference basically between, I have taken the key points out here, and then we are discussing the key feature of this key point in concept of OOPS and then in concepts of procedural oriented programming, right? So first one is the definition. So I'm not going over to the reading this particular definition. I'm just giving you the concept that object-oriented programming is going to use the classes and objects. The main concept of object-oriented programming is the classes and the objects, which is based and which is created according to the real world environment, right? So what we can see in the OOPS, it makes it easy to maintain and modify the code, easy to maintain and modify the existing code as new objects are created, inheriting characteristics from existing ones. In the concept of procedural oriented programming, what we can see is, first of all, it does not have classes or objects according to the real world entities, while we just follow a step-by-step approach, due to which we are doing what? We are breaking down a particular task into variables and routines or subroutines. We call it as functions in this concept, procedural oriented, we call it as functions, right? So this is what? This is a step-by-step sequence of approach in which we are going to solve a particular task, and this particular task is to be broken down into the collection of variables and routines. Now here we do not have any option of reusing of code, as we have already defined in OOPS, that is, we can easily maintain the code and we can modify the existing code, but here it is not so easy to do in procedural oriented programming because we cannot reuse the code. Why we cannot reuse the code? We cannot reuse because we do not have the classes or the objects created according to the real world entity. Now what approach it is using is, the concept of objects and classes is introduced, and hence the program is divided into chunks, small chunks called objects, which are instances of classes. So we have already seen what are objects. Objects are just the instances of classes. So when we define a particular problem, that particular program is divided into chunks, means into small modules, right? So we are using a modular approach in this concept of object oriented programming. While when we talk about the procedural oriented programming, what we are doing here, the main program is divided into small parts which are called as functions, and they are treated as separate programs for individual smaller programs. So here what we are using, we are not using the modular approach, we are using the functions in the main programs, where these particular main programs are divided into small programs, or I won't say it's small programs, but small parts, which are called to be as functions, right? While here we do not have any functions, here we have objects and classes. Now the access modifiers. This is a very good feature of object-oriented programming. We can have access modifiers in the object-oriented programming. Example, as I have already told you in the earlier lectures of object-oriented concepts, in which we have defined the access of the classes, which can be defined as private, public, and protected, right? And these particular access modes have the features as plus sign, minus sign, and so on, which can define whether that particular can be accessed privately or publicly, right? So, but we do not have any feature of modifiers in the procedural oriented programming. So this is again a very good feature provided in the object oriented programming. Fourth point, we have the key point as the security. Now we know that data abstraction and data hiding is possible in the object-oriented programming, as encapsulation and data abstraction are what? These are the two key characteristics of object-oriented programming, in which we hide the data with the focus point of in which we have security version, that is to keep secure the data we hide the data, right? So that particular is what? That particular is defined in this concept of object oriented programming, while which makes it what? Which makes it more secure as compared to the procedural oriented programming. We do not have any option of data abstraction or encapsulation in the terms of procedural oriented programming. So we can say this particular is less secure, right? Next we have the complexity. Now, as we all know that the approach we are using in object-oriented programming is the modular approach. Modular means what we are doing, we are taking a particular complex task, and that particular complex task is divided into small parts, which can easily be provided as a solution. And this is a very good feature of modularity, which reduces the complexity in object-oriented programming. So OOPS, due to modularity in its programs, is less complex, and hence new data objects can be created easily from existing objects, making object-oriented program easy to modify. So what we can do is we can create new objects from the already existing objects, right? We can add some features to it, and we can use the features in the existing one also. But when we talk about procedural oriented programming, this feature is not available, so the complexity is not reduced in this part, right? Now, second topic of this lecture is programming style. Now, we have to see that what programming style we need to figure out and we need to use to make a good program, right? So, whenever we say that if a good programmer or experienced programmer is there, he is going to follow certain principles for creating or developing the programs. Now, what are those particular programs? Basically, in the object-oriented design and programming, we have the key features which are called as reusability, extensibility, and understandable programs. These are the key features of object-oriented programming as in programming style. So according to the object-oriented programming, a good programming style will include certain features which a programmer, an experienced programmer or a good programmer should take care of. What are these styles? We are going to see that. First one, it is called as reusability. Second one, extensibility. Third one, robustness. And fourth one as programming in large. Now we are going to see one by one what are these particular characteristics are. So first one is reusability. Now first thing is, what do we mean by reusability? See, reusability is if we can reuse a particular thing which was already used and created, and we can reuse it, we can use it again. Now this particular reusability can be of two kinds, right? Two types can be of reusability. What are the two types? The two types are, the first one is when you are going to share a newly written code within a project, right? If let's say you have written a new code and you are sharing this particular new code within a project, right? So that with a perspective that this particular code can be reused by some other programmer, right? Second one, we can reuse the previously written code on new project. Somebody has already written a code and we are using that particular existing code again in a new project. That particular is again a concept of reusability. So basically, there are two ways in which we can say the reusability is done. So these are the two things, right? Now, what are the styles? What are the style rules for reusability? We have to make sure that our methods are coherent. Coherent means we have seen earlier also two things. One is called as the cohesion, if you all remember, and the other one is called as the coupling, right? One is called as the cohesion and second one is called as the coupling. Now what was this? This was when we use a modular approach, we see two characteristics in concept of cohesion and coupling. What are these? There should be good amount of cohesion but low degree of coupling among the modules, right? So what is it basically? Cohesion is the binding of all the elements together within a single module, while coupling is interaction between the two modules. So we should say that there should be less of coupling because there should be less of interdependency among the two modules, so that if one module is being affected, it should affect at less degree to the other module. And second one is there should be good cohesion, good degree of cohesion. Why? Because a module is binded together with all the elements with the binding of all the elements together. So there should be good cohesion within a single module. So we have to keep the methods coherent. They should be binded together. The methods should be small, they should not be very large. And lastly, we should keep the methods consistent. Consistent, we all know, consistent means we should make it the same way, right? Same pattern and same names should be given to the modules, same features should be there, etc., etc. Now, next one is using inheritance. How do we use inheritance? We use inheritance in terms of subroutines that we will see in the code part, right? So this was the first concept of programming style, that is called as the reusability. Second one is termed as the extensibility. So first of all, let me tell you what is extensibility. Extensibility is any measure of the ability so that a program can be extended. A program can be extended to a system. That means it is a measure of the ability to extend a system and the level of effort required to implement the extension. Now this particular, that means if we have an existing program and we are trying to extend that program. So that is what, that is extensibility. Now this extensibility can be done in two ways, right? One thing is we are going to add a new functionality to the existing program. First thing, let's say we have one more module to be added or one more function to be added in an existing system or in an existing software. This is the first concept of extensibility. And second, let's say there is modification of existing functionality. There are some changes in the existing functionality. This is again a term of extensibility, right? Again, a new form of extensibility. Third one is what we say, this is what the extensibility is. Now what we have to see, or what is the goal of extensibility? The goal of extensibility is we can add the new feature or the new functionality to the existing one, or the changes can be easily done to the new functionality, existing functionality, but it should not affect the existing system functions. So the principle of extensibility is what? It should provide for enhancements without impairing existing system functions. That means we are going to do changes, we are going to modify, we are going to add, delete, update new functionalities or existing ones, but the existing system function should not get affected by this enhancement. This is the key feature of extensibility, right? Now, next one, the third one is called as the robustness. Now, what is this robustness? Robustness is, uh, it is a style that focuses on handling unexpected termination or unexpected actions. That means whenever there is a program that is terminating unexpectedly or some unexpected actions is being done, that particular style is being focused in robustness. This should not take place, right? No unexpected actions or terminations should be there in a program or in a code. If at all there is, these particular codes should be handled properly so that accurate messages are shown or displayed on the screen, right? So it is a style that focuses on handling unexpected termination and unexpected actions. Second, it requires code to handle these terminations and actions properly. So we should take care and we should generate the code so that these actions and unexpected terminations, if are taking place, they should be properly handled and a proper accurate error message should be displayed, so that these error message can help or allow the users to more easily debug the program, right? Example, let's say we take in a simple example. Let's say you are submitting a form, right? And in that form there is a field which has asterisk, and that particular field is what? That particular field is, if you are that is a necessary or the compulsory factor which you have to fill. That means if you are keeping it empty, that particular form will not be filled, right? So in that case, you can see in some cases there are conditions that if you do not fill that particular field, what happens? And you submit the button, you click the submit button, what gives it? Sometimes give you an error message. What? That this field is compulsory, so you should fill it, and it takes you to the cursor to that particular field. So this is the way how these particular can be handled. A proper error message is given to the user so that it is easy to understand to the user why the program is not functioning. There can be the other way round of this same scenario. What is the other way round? There is a point where we have not filled the necessary or the compulsory field, right? And we have clicked the submit button. Now it is neither submitting nor it is moving to any other error message, right? Only the same screen is coming to you. Now you are puzzled why this particular submission is not being done. मैं submission button को click कर रही हूँ, मैंने form fill कर दिया, but this is not getting submitted. Why this is not getting submitted? I cannot easily find out, right? I have to figure it out why this is not being submitted. Because let's say I'm a common person, I do not know that this particular field is a compulsory field and I should fill it. So this particular code where this error message is generated if this field is not filled. So the submission will not take place and it will give an error message. So this is called robustness, right? Those unexpected actions or unexpected terminations will not take place, and if it all takes place, it should display an accurate message for the user to debug the program easily, right? Now last one is the programming in large. This is the fourth feature. What is this? Programming in large can refer to the programming code that represents the high level state transition logic of a system. So there are two things. One is programming in small and the other one is called as programming in large. When we say programming in large, it means to say that there are multiple programmers who are working on a same scenario on the same project, and they are working on different programs, different languages, different programming languages, and they are generating the codes. So there arises certain problems, so those particular problems are to be taken care in terms of programming in large, right? So what are the things? We should take care of certain guidelines. They are like, do not prematurely begin programming. We have to take care, we have to be mature enough, and we have to take care of all the features which I am going to say it, and we should then move to the programming when we have cleared the design and it is published to all the programmers. Keep methods understandable. That means all the methods should be understandable to all the programmers, not only to the one or two. Make methods readable. Methods should be readable. Use exactly the same names. This is very important as in the object model. Whatever object model we have created in the programming also, we are going to use the same names. Choose the names carefully, so there should not be any confusion regarding the names. Let's say we have student one class and the other class is for the scholarship students. So we have to clearly mention that student is one class and the subclass of this is what? That is scholarship, SCH underscore student. So it should be very clear with the name. Use programming guidelines. Whatever the programming guidelines is, that to be taken care of. Package into modules, that means we have to create the packages. We have already understood and learned what are the packages and how do we create it. Documentation should be done properly of the classes and methods, and publish the specification means that these particular whatever specification we are using, that should be published to all the programmers who are working on the same project, right? So that's all for this particular lecture session. Thank you very much.